As a technician, you'll often find that troubleshooting problems with a laptop can be challenging. These are very unique computing environments that are specifically designed to fit a particular form factor. And because of that, it can be a very challenging repair if you need to get inside of that device and make a change. You might often find as you look at laptops from different manufacturers that some laptops tend to be easier to repair than others. You'll often become very knowledgeable in one particular manufacturer's laptops because that's the one that your organization will tend to purchase the most. And you'll find over time you'll become much more comfortable with repairing those particular brand of laptops. Many laptop manufacturers will provide service information so you can learn more about the process required to replace the keyboard, the display, or other components within the laptop. Our laptops are mobile devices, so it's important to have some type of power source when you're traveling. Many laptops will have batteries included, and usually these batteries are very modular. You can unplug and reconnect those batteries to your laptop, and you don't have to take apart the laptop to gain access to that battery. Some laptops will have batteries inside of the laptop case, and those obviously are not designed to be modular. Many of the battery technologies we use today are lithium-ion or lithium-ion polymer. These batteries are designed to be fully charged. You can discharge some of the battery and charge it back up again without worrying that you're causing a memory effect or limiting the amount of capacity that battery might have. However, each time you charge that battery, it diminishes the capacity just a bit. So after a number of years, you may find that you have to replace the battery because it's not able to maintain the charge that it once did. Because laptops have a very specific form factor, you'll find that the batteries used in these laptops are very specific to a particular make and model of laptop. So if you're purchasing a new battery for a laptop, make sure you're purchasing it specifically for that particular device. Here's an example of a very modular battery configuration on the back of a laptop. There are two different batteries underneath this empty space, and you can see they will slide in and lock into place. You can unlock the battery with the switch that's on the back, pull it out, and replace it with a new battery. This means if you're traveling and you use up the capacity of one battery, you can easily disconnect that battery and connect a fresh one to your laptop. The keyboard is probably the most used component of a laptop. It is our primary input into the operating system, and fortunately, it's a very easy component to replace. There's a single device that's usually connected with a ribbon cable to the main part of the laptop. This is the back of a laptop keyboard, and you can see there is this single ribbon cable that's used to connect and disconnect from the laptop motherboard. You do have the option on many laptops to plug in an external keyboard to a USB interface. So if you're running into problems with the keyboard that's integrated into your laptop, you may be able to work around those problems by using an external keyboard. One of the challenges we have with laptops is as the laptop becomes smaller, there's less space to have a keyboard. So we're using a lot of extra function keys and changing around the layout of the keyboard just to be able to fit it into this small place. You can see on this laptop that we don't have enough room for a numeric keypad on the right side, and the inverted T that we use for arrow keys is put underneath the Shift key on the right side. Some larger laptops can include other keys. For example, this laptop does have a numeric keypad, but you'll notice a lot of the function keys for home, in, page up, and page down have been moved just above the numeric keypad. And you can also see that the function keys also have secondary functions associated with them. So the key that you would normally use for F1 has a question mark, which is probably the help key for this particular laptop. Function 2 looks like it is a brightness or brightness down setting, and F3 is a brightness up setting. The way that we would access those secondary functions is to hold down the function key on the keyboard and press the appropriate key on the function keypad. Because these laptops are mobile, we tend to sometimes have things fall within the keyboard itself, or the keycaps themselves might be damaged and we might have to replace them. These keycaps, though, are very fragile, so make sure you check with the manufacturer's instructions and you follow exactly what they recommend when changing anything with that keyboard. You don't want to break any part of the keycap itself when you're removing it or placing it back onto the laptop, and you want to be sure that the mechanics underneath are not damaged at all. This picture shows just how delicate these tiny little plastic pieces are underneath the keycaps, so you want to be very, very careful when doing any type of maintenance on that laptop keyboard. All of the programs that are executing in your operating system are executing in memory. And if we ever need to increase the amount of memory in our laptop, then we'll probably want to use SODIMM, or the Small Outline Dual Inline Memory Module. This form factor is very common for laptops and other mobile devices, and often there is a window or an opening at the bottom of the laptop that allows you to easily add and remove these memory modules. Some laptop manufacturers have decided not to create a modular way to change the amount of memory inside of the laptop, and in those cases, the memory's not on a SODIMM module. Instead, it's physically soldered to the motherboard of the laptop. This means that you can't upgrade or change the amount of memory in that laptop, and if you needed to make a change to the memory, you would have to replace the entire motherboard for that laptop, and that is certainly a very costly endeavor when all you might want is additional memory in your system. Here's a picture of a SODIMM. This one is in context with everything around it. So you can see this is a relatively small memory module, especially when you compare it to the larger DIMMs that you might find inside of a desktop computer. To be able to install the SODIMM, you place it into the memory slot on the laptop, push it down so that it locks, and now you have additional memory in your laptop. Our laptops also need some type of storage space so that we can retrieve or save files to that system. Older laptops might have storage in the form of a magnetic disk. This is the hard drives that we traditionally think about. These are spinning physical drives, but they're in a form factor that's around 2.5 inches. This 2.5-inch form factor works well for these portable platforms, especially when you consider that desktop platforms have the larger 3.5-inch size hard drives. Many newer laptops will instead have solid-state drives, or SSDs, instead of spinning hard drives. As the name implies, a solid-state drive is solid-state. There are no moving parts inside of an SSD, even though the SSD shown here in this picture looks identical to the form factor and connectivity you might have for a hard drive. This makes it very easy to perform an upgrade because you can unplug a hard drive and connect an SSD to the same interface using exactly the same form factor. One significant advantage of the SSD is the greatly increased speed for reading and writing data to this device. And by simply upgrading from a hard drive to an SSD, you can greatly improve the performance of almost any device. There's also another interface type available on many devices called an M.2 interface. This is an M.2 interface on an SSD drive, and you can see the size of this SSD is much smaller than the larger and more traditional SATA-connected SSD. This means we can fit a lot more storage in a much smaller space, and we don't have the cables that you would normally find on a traditional SATA-connected SSD. This is also a very modular form of storage. You can simply plug it into a slot, use a screw to connect it, and you now have additional storage inside of your system. Here's another view of these two storage devices together. One is a spinning hard drive with a SATA connection. The other is an SSD using an M.2 interface. And you can see these are two different kinds of connections using a very different form factor inside of the laptop. If you need to replace or upgrade the storage that's inside of your laptop, you may find that everything is internal to the laptop and you have to open the entire back of the laptop to gain access to that particular storage bay. Or there may be a window or an opening on the back of a laptop and you simply need to open one single window to gain access to the entire storage area. Whether these are drives that are inside of the laptop or they're accessible from a cover on the back of the laptop, they're relatively easy to replace. There are probably a few screws you would remove. You would disconnect it from the SATA connection that's on your laptop and then slide it out of that particular bay. To add a new drive, you simply plug it into the cable, screw it down, and now you have a new drive inside of that laptop. If you're connecting to an M.2 interface, it's even easier. It's a single screw that allows you to either connect or disconnect that M.2 drive, and it simply slides out of that M.2 interface, very similar to the interface you would use for installing memory on a system. This laptop happens to have a cover in the back that gains access to the storage drive. You would unscrew that cover and remove it from the system, and then unscrew the mount that is keeping that drive in place inside of the laptop. On this laptop, you simply slide the drive back, which disconnects it from the SATA connection, and you can remove it from the laptop. It's a similar process if the drive is inside of the laptop without an access cover. You'll just have to remove the entire back of the laptop to be able to gain access to that drive. And if you're lucky enough to have a laptop with an M.2 connection, there's probably a cover on the back that you can remove, and then you can add the SSD, use the single screw to tighten it down, replace the cover, and now you have a new storage drive on your laptop. Because the performance of a system can be improved dramatically by replacing a spinning hard drive with an SSD, it's very common to perform these migrations and move an operating system from an existing spinning hard drive to a new SSD on these laptops. You can do this a number of different ways. One common way to do it is to install an operating system on the SSD and simply move over a user's documents and any applications that they might need. However, this can be time-consuming because it requires an additional operating system installation, and then you have to manually move over everything that user might have in their user documents and then manually install any applications that are important for that user. Another way to migrate from a hard drive to an SSD, and a method that's perhaps more elegant, is to create a clone or an image of the hard drive and move that image to the new SSD. This means that you don't have to install a new operating system on the SSD, and when you move this image from one system to the other, you're moving everything, all of the user's data and all of the user's applications. To perform this migration, you'll need software that can create the image on the hard drive and move that image or copy it onto the SSD. There are a number of applications that can do this. Many manufacturers will include an application with the SSD that can provide this imaging function, but there are many commercial and open source options available. Some organizations will create one single image file and use that image file to create multiple copies across multiple systems. You can also perform a drive-to-drive image where there's no intermediary image file. You're simply taking everything from one system and copying it sector by sector over to the drive that's on another system. This would require that you either have two systems running simultaneously so you can perform that drive-to-drive image, or the system that you're using supports having multiple drives inside of it simultaneously. On many newer laptops, you may find that wireless functionality using 802.11 or Bluetooth connections are built into the system board or motherboard of that laptop. Older laptops may include Mini PCI or Mini PCI Express interfaces so that you can add additional wireless connectivity. For example, you could plug in one of these cards and you might have 802.11 access that will provide you with local area network coverage on wireless networks. Or this may be a Bluetooth connection so that you can connect over a personal area network to earpieces, speakers, and other Bluetooth components. This is designed to be user replaceable, so there's usually a cover that you can remove on the back of the laptop that will allow you access to the Mini PCI or Mini PCI Express interfaces. This is an older laptop that has a couple of storage bays. Here's the memory in the middle of the system. There's some cooling here for the CPU. And you can see right here on the bottom right are two Mini PCI Express interfaces. One of these is for wireless local area network, and the other is for a wireless personal area network or Bluetooth. Here's a better view of these. There's actually 3 slots available on this laptop. We're using 2 of them, one for 802.11 and the other one for Bluetooth. But there's a slot right in the middle specifying for wireless wide area network, which would be a cellular connection so that you can use a third-party cellular provider to gain access to the network when you're away from 802.11 or any other type of network. These cards are very modular, so it's very easy to slide one into a slot, push it down, and you've installed the card. For these wireless cards, there are usually antenna wires connected as well, so you would connect those to the appropriate ports on that wireless card. Our newer operating systems may provide us with additional authentication options, which can be really useful on a laptop computer. For example, instead of typing a password to gain access to the system, you might want to use biometrics. Our operating system can look at our face, it can look at our fingerprint, and be able to determine if that's really us and if we should gain access to the system. There are usually two components to this. There's the software in the operating system so that it can support this method of authentication, and then you'll need some type of hardware that can provide either the view of your face or the view of your finger so that it can determine if that's really you wanting to gain access to the laptop. If you look at the options for authentication in your account settings in Windows, you'll see the different options that are available. We're all very familiar with the password option, for example, but if you wanted to use biometrics, you could use Windows Hello Face, which will use the camera on your system to look at your face, or use Windows Hello Fingerprint, which uses a fingerprint reader. Since it's difficult to duplicate your face or your fingerprint, these are relatively secure ways of authenticating into your laptop. And in some cases, you might use multiple forms at the same time to provide additional factors of authentication. For example, you may have to type a password and use your fingerprint just to make sure that you really are the person gaining access to that laptop. This is the laptop keyboard we were looking at earlier. You can see on the right side, underneath the keyboard, is this small sensor. That's your fingerprint sensor. So to be able to authenticate to this system, you simply slide your finger across that sensor. It will recognize your fingerprint and give you access to the operating system. We're also seeing NFC, or near-field communication, being used more and more with laptops. It's a technology we've been using for quite some time on our mobile devices. Now we're starting to see it integrated into our laptop systems. This allows us to transfer data or perform authentication to the device without physically touching the device. If you're in a store and you paid during checkout with your phone or your watch, then you were using NFC. But you could also use your phone or your watch to authenticate to the laptop. This is great if you're in a hospital or a warehouse where you might be using this laptop only occasionally and you need it to quickly authenticate each time you walk up to the laptop. By using your phone or your watch, you're able to provide that authentication without having to touch anything else on the system, input any extra passwords, and quickly gain access to the operating system.